Welcome to Escape Velocity Space News. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. Today, we're going to take a look at two parallel stories: the development of the Vera Rubin Observatory and the development of the SpaceX Starship rocket. It's unclear when Elon Musk first decided Mars was his destiny, but he has been talking about a SpaceX heavy lift rocket since 2005, just a few years after the 2002 incorporation of SpaceX. The LSST Discovery Alliance was incorporated in 2003 and began building collaborations and seeking funding immediately. Neither project hit their planned timeline, with LSST planning first light in 2019 and Musk planning to achieve orbit with Starship in late 2019. 6 years later, Rubin has given us the most amazing demonstration of its functionality, and it is performing final calibrations and system setup right now. At the same time, Starship still hasn't tried to launch for orbit, and its last several vehicles have all met a fiery end, with Ship 36 exploding while sitting on a test pad getting ready for an engine test. In our first segment, we're going to celebrate Rubin Observatory and look at the 20 years of development that went into bringing us a stubby, zoomy telescope. Seriously, this telescope has a focal ratio of f1.234, and it is a squat, light-capturing monster of a machine. In our second segment, we're going to switch gears and look at what SpaceX promised, what they've delivered, and what new delays their massive explosion will add to programs like Artemis. All this and more is coming to you right here, right now, on EVSN, a product of CosmoQuest X, and supported through our Patreon. In the early 2000s, the massive scientific return from the Sloan Digital Sky Survey made it clear that there are questions we can only answer by investing in systems that survey the sky and inventory everything visible. From learning about the distribution of galaxies by type to exploring the distribution of stars by age, that survey gave us a glimpse of just how much we don't yet know. The SDSS survey used a 2.5-meter telescope to initially explore an 8,000 square degree area of the sky, and it has since added new areas and new specialty programs with both imaging and spectral capabilities. This workhorse of a system has given us a three-dimensional map of our galaxy and the surrounding universe, or at least of the regions in that initial 8,000 square degree region, and the smaller regions added later. The data was amazing, and in some instances, repeated observations allowed us to catch transitory behaviors. But the Sloan Digital Sky Survey was not designed to show us how the sky changes. It was designed to map a moment in time. And its data made us want more. It made us want a larger telescope that could look at a larger region of the sky and that could get us data night after night after night that would let us see everything that flickers, flares, and moves in the sky. We wanted supernovae. All of them, please, and thank you. We wanted large-scale structure, the whole sky if possible. We wanted to find every potentially deadly asteroid and every pulsating variable star. We wanted data. The kind of data technology didn't even exist to store or transport. But nothing gets between an astronomer and their data. Well, nothing except time and money. Well, folks had been talking about a giant telescope to do a giant survey since the 1990s. It would take the Sloan Digital Sky Survey's success to get all of us on board. The 2010 Decadal Survey for Astronomy made that giant telescope, then called the Large Synoptic Survey Telescope, or LSST, the highest priority in astronomy. The collaboration was built, private donors were chased, the mirror was started in 2007, grants were applied for, construction in Chile started in 2014. The LSST would be an 8.4-meter telescope with an excessively wide 3.5-degree diameter field of view and a prime focus camera that would redefine astronomical imaging. For those of you who know telescopes, again, this monster has a 1.234 focal ratio. The LSST camera combines 189 4K by 4K CCD chips into a massive array, with each pixel capturing 0.2 arcseconds of sky. Put another way, if you were to hold a hair at arm's length, it's 1 arcsecond wide. An LSST would have 5 pixels imaging that hair's width. It's really hard to comprehend just how much data is in each LSST image. I wrote this episode with a 43-inch 4K monitor in front of me. My eyes couldn't make out individual pixels, and it only has 3,840 by 2,160 pixels. One image from the LSST camera would require more than 200 of my monitors just to look at the bottom 2,160 pixels. Those more than 200 monitors would span more than 2 football fields. Now, I don't have great eyeballs, and my monitor is not a retina display. If you have perfect eyes, you could smash things down, but folks, it would take 212 yards of 43-inch 4K televisions to see the bottom section of one LSST image. These are big images. Construction of the telescope was largely completed by last October. And in the 10 years since its groundbreaking, a lot of things have changed. The Large Synoptic Survey Telescope was named the Saminier Telescope after its largest private donor. That happened back in 2018. The observatory was named after Vera Rubin, the woman whose data made us believers in the invisible dark matter that permeates our universe. The 10-year survey was named the Legacy Survey of Space and Time. So when we continue to say LSST, it still makes sense. Oh, and on the way to first light, amazing technological problems were overcome. Each night, LSST will capture 20 terabytes of data. In its first year, it will collect more data than all other observatories have captured since we started using digital detectors in the 1980s. Initially, it was thought we wouldn't be able to store all this data, and limitations in internet infrastructure would mean everything got reduced to tables of what brightness appeared where. This was unsatisfying. But amazing work done in conjunction with Cisco Systems has created a data transfer backbone capable of transporting each night's data to both the National Center for Supercomputing Applications in Chicago and the French National Institution of Nuclear and Particle Physics in Lyon, France. Data is also passed to other U.S. facilities, including SLAC and the University of Arizona, where LSST is headquartered. Unfortunately, we won't be able to get up each morning and just scroll through the images. This system is so sensitive that there are legitimate concerns that military technology in orbit could be revealed in the raw data. So we'll get the raw data just on a 2-year delay. Instead, machine learning algorithms will do a first pass, pulling out all the potential asteroids, comets, supernovae, and other moving and changing objects that may need immediate follow-up observations. It's anticipated that the survey could generate 10 million alerts per night as it finds all the transient objects from gamma ray bursts to near Earth asteroids. In 11 massive data releases, researchers will get dumps of the LSST's 10 years of data. It's expected to catalog 20 billion galaxies, 17 billion resolved stars, and as many as 6 million solar system bodies with well defined orbits. If there's an asteroid out there eyeing Earth as a target, Rubin will find it. And if there's a Planet 9 or Planet 9 through N out there lurking in the outer solar system, Rubin will find it or them too. On Monday, June 23rd, the Rubin Observatory team released 2 images built from multiple exposures of the region containing the Trifid and Lagoon Nebula and the region around the Virga cluster. This was just 10 hours of data, and they already captured millions of galaxies and stars and thousands of asteroids. In fact, that Monday morning, they submitted 2,104 new asteroids to the Minor Planet Center outside Boston. It's estimated that Rubin will bring the total number of known asteroids to 5 million. We don't yet have details on if LSST meets or exceeds its design specifications. But those images let us know this telescope, it's enough. As expressed by Matt Mountain, quote, "It is not every day that a revolution stares you in the face, but that is precisely what the Rubin Observatory team, together with our colleagues at the National Science Foundation and the Department of Energy, has delivered with those first images. Astronomy is on the brink of transformation." End quote. LSST will map out the sky from 12 north to 72 south, a region 18,000 square degrees in size. Each 30-second exposure in one of 6 filters will reach magnitudes 22 or higher. That's fainter. Every point in the survey will be imaged roughly 100 times per year. And we're going to have literal movies of stars moving, asteroids and dwarf planets orbiting, and stars pulsating over days and years. When I was an undergraduate in the 1990s, folks joked about how a sample of 6 objects was statistically interesting, and for some kinds of things was actually a large sample. LSST takes that 6 and asks, would you like that to be 6 million or 6 billion? Right now, the Rubin Observatory team is finishing the checkout process, putting the telescope through all its motions and fine-tuning how it works. Later this year, the survey will start in earnest, and we can expect data release 1 toward the end of 2026. I'm hoping we'll start seeing science maybe as early as the AAS meeting in January. And as soon as we have it, we'll be bringing it to you right here on EVSN. Up next, we're going to switch gears from joy and success to things that explode without warning in the middle of the night. Stay tuned. I think it's fair to say that humans have dreamed of going to Mars for as long as we've known Mars is a planet. We see these dreams in amazing books like the Martian Chronicles and John Carter of Mars, and even in Percival Lowell's attempts to map what we now see as fictional canals. Humanity's first successful Mars mission was the 1965 Mariner 4 flyby, and today 2 U.S. rovers explore the red planet's surface. Mariner 4 was 60 years ago, and if the dreamers get what they want, we will have humans on Mars before the 70th anniversary of Mariner 4. I'm just not sure that is going to happen, and I want to look at the facts behind this potential fiction. Musk has been talking about his desire to have a fully reusable Mars vehicle since at least 2005. And in 2012, Musk told the BBC that he planned to have a fully reusable system tested with flights around the moon in the early 2020s, with humans landing on Mars in the 2030s. He anticipated getting the cost of a round-trip ticket down to $500,000, which he felt would allow the average person a chance to visit Mars. I'm not sure 500,000 will ever be affordable to the average person, but this was an amazing dream for researchers who could imagine getting massive NASA grants to go rock hunting on another world. Before I go on, I want to make an aside. I'm going to be saying Musk planned instead of SpaceX planned because the documents and interviews I read while writing this segment, unless stated otherwise, all cite things Elon Musk has said. SpaceX has had amazing people over the years, but the vision for SpaceX that I'm discussing belongs to Musk. Back in 2005, the rocket that would take us to Mars was the Big Falcon rocket, or BFR. It was planned to launch 100 tons to LEO, or low Earth orbit, using Merlin 2 engines. By 2010, this had evolved to include 6 massive engines capable of carrying 140 tons to LEO on board a carbon fiber vehicle. And in 2012, Chief Operating Officer Gwen Shotwell was saying SpaceX would launch 150 to 200 tons to LEO and 100 tons to Mars. But that's not all. By 2016, when the first Raptor engine was tested, Musk said his carbon composite rockets would launch 200 tons to LEO with a low launch price and would have versions capable of serving as a Mars colonial transporter. The rocket would have 3 versions: crew, cargo, and tanker, with plans to refuel both at Mars and in Earth orbit. Carbon composites are hard to work with, however, and in 2018, designs got scrapped. Production got moved to Texas, and the carbon composite BFR was transformed to a steel Starship. In May 2021, NASA contracted SpaceX for $2.89 billion to manufacture, test, and then provide a version of Starship designed to land on the Moon for Artemis 3 and 4. The published timeline had Artemis 3 landing in 2024 after performing an orbital launch test in Q2 of 2022 and a propellant transfer test in Q4 of 2022. An uncrewed landing of Starship HLS, which is what I'm talking about, was planned for Q1 2024. It was expected that a crewed human launch system version of Starship would take place in the first quarter of 2025. We are now in Q3 2025, and an orbital launch test has yet to be attempted. And new estimates of launch capacity are not 200 tons to low Earth orbit. They're 100 tons to LEO. To be fair, the NASA Office of the Inspector General had noted as early as November 2021, half a year after HLS was awarded, that things were going to not be on time. The degree of not on time, however, needs reported on. The first big issue SpaceX encountered was the destruction of their launch pad that occurred in April 2023 when they rushed their launch of Rocket 7 with Starship 24 on April 20th without installing anything to absorb or dampen the acoustic energy from their engines. Yes, folks, they rushed to launch 24/7 on 4/20. And as a result, they blasted apart their cement launch pad, scattering material for miles. So the first launch attempt was a year after they were supposed to reach orbit. Moving on. In the years and test launches since then, they have attempted 9 launches and destroyed 10 Starships. When the number of spacecraft destroyed exceeds the number of launches attempted, we have a problem. Launch 1 entered an uncontrolled spin prior to booster and Starship separation, and the flight termination system was engaged to blow things up before they hurt something. SpaceX called this a success. Launch 2. The booster and Starship made it through separation before a booster engine exploded and took out the booster. This was attributed to a filter blockage. A leak in the Starship caused oxygen venting, and the flight termination system was used to destroy the ship at 149 kilometers altitude. SpaceX called the mission a success. Launch 3. 6 booster engines failed during ascent, and only 3 ignited during re-entry. Again, a filter blockage occurred. Starship failed to reignite engines, and control was lost. SpaceX called this a success. 4. The booster worked for the most part, but the Starship had a significant amount of damage due to heat during reentry, and splashdown wasn't where planned, and the vehicle was scorched beyond full functionality. Again, this was marked a success. 6. The booster was caught, and Starship again had flap damage and got scorched, this time exploding as it hit the water. A success? 7. The booster was caught, but Starship exploded over Turks and Caicos and wrecked air traffic. Success. 8. The booster was caught, but Starship again blew up over Turks and Caicos, this time shutting down airports as far away as Florida. 9. The Super Heavy blew up over the Gulf of Mexico, with chunks washing up on beaches where they got in the way of baby turtles trying to make it to the ocean. Starship spiraled out of control and broke up over the Indian Ocean. 8 and 9 were both labeled successes. And then, on June 18th, while on the Macy test stand at Starbase in Texas, Starship 36 spontaneously exploded after being fueled and prior to the start of an engine test. SpaceX admitted this was a problem. And then, while trying to clean the facility, a crane collapsed on June 25th. It is unclear how long it will take to rebuild the Macy test facility. I've seen some rumors that SpaceX may race forward without doing engine tests, and frankly, that terrifies me. In November 2024, SpaceX was rebuked by NASA for safety concerns that included all 4 astronauts and a Crew Dragon needing brief hospitalizations after an ocean landing. There have been a lot of safety concerns around the most recent Crew Dragon Axiom 4 launch, as we mentioned in the last episode. And we are seeing stories on social media of Starship workers sleeping and leaving all manner of garbage in Starship as they struggle to keep up with the demanding pace of activities. The first launch of Starship occurred 1 year after they were supposed to reach orbit. A year after they were supposed to carry humans to the moon, they still haven't reached orbit. While it was originally documented in 2021 that Starship would take 4 to 8 refueling missions to reach the moon, more recent NASA estimates place the number at closer to 20 or more launches. It is unclear how Starship will get the Artemis crew to the moon this decade. It is unclear to me how they will accomplish 20 or more fueling only launches, in the 54 months left in this decade, when they still haven't made it to orbit. As of February 2024, an article on NASDAQ estimated Starship would cost $10 billion to develop, which exceeds estimates of the New Glenn's costs. And New Glenn has launched and gone around the moon. While SpaceX hopes to get Starship costs down to $10 million per launch, Space Insider estimates Starship tests are $100 million a pop, while New Glenn is more like $68 million a launch. Space Launch Systems, or SLS, which everyone at SpaceX seems to discuss as outlandishly expensive and in need of cancellation, it's estimated to be $23.8 billion to develop, just over twice as much as Starship. And again, SLS already had a successful launch that flew past the moon. Folks, every day on the internet, I see people talking about how Musk is the one person capable of getting us to Mars. I see calls to cancel SLS and people mocking Boeing for problems that haven't actually caused any crashes or explosions that caused the kinds of damage we're seeing from Starship. I see calls to end regulation and just allow SpaceX to fly forward doing what they will without FAA, FCC, or EPA oversight. And I see a company blowing things up and calling it a success and sending astronauts to the hospital. And I just don't get it. I don't understand why we aren't publicly changing plans and being upfront that if we want to get astronauts on the moon in this decade, we need Blue Origin to swap in with their Mark II lander. By the way, it looks like they've already delivered their Mark I lander to Kennedy ahead of their August New Glenn launch. Okay, what I said about not getting it was a partial lie. I know why a lot of us don't cover these problems. This story will cause us to get hate mail. It will cause people to unsubscribe, and I'm likely going to anger some folks at NASA who may one day be reviewing my grants or press credentials. Reporting on this story has risks, and it will potentially have financial consequences to our programs. But I remember Challenger. And the first breaking news story I covered as a journalist was the explosion of Columbia. I have chosen, and our staff at EVSN has chosen, to speak the truth no matter the consequences. And we're grateful to everyone at our Patreon for allowing us this freedom. What I don't understand is why I learned about the issues with HLS refueling from Destin over at Smarter Every Day instead of from NASA initially. I want to understand why people tasked with keeping astronauts safe aren't being louder about current risks. And I'm worried that it will take the loss of human life before a proper investigation of safety issues at SpaceX facilities is performed. And because of these concerns, we're reporting the facts and encouraging you to ask, do you want to see a proper safety investigation now or after someone dies? I know my answer. Up next, we look at this week's Tales from the Launch Pad. Stay tuned. Right now, Erik is off chasing down things that are in the process of happening, and while he does that, which I admit was very cryptic to say, I'm going to bring you the rocket news. On June 7th, SpaceX launched the SXM-10 mission from Slick 40. Let's watch the launch.
5, 4, 3, 2, 1. Ignition and liftoff. Go Falcon, go Sirius.
Vehicles pitching downrange. Stage 1 propulsion is nominal.
SXM-10 is the latest satellite for Sirius XM, the satellite radio provider. The satellite uses a single large reflector dish to deliver its service and can generate 20 kilowatts of power from its solar panels. On June 11th, Rocket Lab conducted the Mountain God Guards mission from their New Zealand spaceport. Let's watch the launch.
5, 4, 3, 2, 1. Liftoff.
Beginning pitch off.
On board was another satellite for IQPS, the Japanese SAR company. On June 14th, China launched the Xianghang-1 O2 satellite from the Quaiquan spaceport in China. Let's watch the launch. The satellite is also called the China Seismoelectromagnetic Satellite. China developed the satellite to detect changes in the electromagnetic fields related to earthquakes in hopes of improving prediction. The satellite will also be used to monitor lightning. It was named after Chinese scientist Zhang Qian, who invented the first seismometer 1,800 years ago. On June 20th, China launched the ChinaSat 9C satellite from the Quaichang spaceport. Let's watch the launch. ChinaSat 9C is the latest in a series of television broadcast satellites operated by the Chinese government. It was launched into orbit on a Long March 3B. Since there are almost too many mega constellations being launched to count, I'm going to start putting them all in their own segment. Since our last episode, SpaceX conducted 9 launches of Starlink satellites. China conducted 1 launch of SatNet LEO satellites on June 5th, the 4th overall. United Launch Alliance conducted the 2nd launch of Kuiper satellites on an Atlas V rocket on June 23rd. The video of that launch was impressive, so let's watch it.
5, 4, 3, 2, 1. We have ignition and liftoff of the United Launch Alliance Atlas V rocket, carrying satellites for Amazon's Project Kuiper Internet constellation, continuing a new chapter in low Earth orbit satellite connectivity.
We keep track of orbital launches by launch site, also called spaceport. According to RocketLaunch.live, so far this year, the United States has had 87 launches. China has had 36 launches, New Zealand has had 8 launches, Russia has had 5 launches, French Guiana, India, Kazakhstan have each had 2 launches. Japan and Norway each have had 1 launch. This makes the total number of launches so far this year 144. Of those 144 launches, there have been 6 failures, reminding us space is hard. Normally, we close our episodes with a feel-good story of some sort, giving you news that we hope leaves you thinking of something fondly, or at least getting a good laugh. Right now, there just isn't a lot of joy in the U.S. space community. While writing this, I got word that NASA higher-ups are planning reductions in workforce, even though Congress hasn't cut their funding. We're seeing the National Science Foundation cut programs, and they're losing their building. People are afraid to say things too loudly that are negative about what's going on. They're afraid to say, this is wrong, because that's how you get your funding cut. I have to admit, during the first Trump administration, I got a letter from NASA that cut my funding and reprimanded me for having anti-Trump tweets on my personal Twitter feed. The fear is real and it is justified. And scientists need your help. We need folks in the United States to please contact their elected officials and ask them to support continued funding for scientific research, including space sciences. There are amazing tools to help you craft your message at the Planetary Society, and we'll link to them on our website, evsn.tv. You can also directly fund research. EVSN is a product of CosmoQuest, a project at the Planetary Science Institute, a 501c3 nonprofit with more than 100 researchers exploring topics throughout planetary science. Through CosmoQuest, we are lucky enough to be funded through your patronage on Patreon, as well as through one-time donations. We need to finish funding this show and our servers for the year, but once we've hit that goal, I'll be working on fundraising citizen science projects that can support other researchers while leveraging the power of the crowd to accelerate research. We've apparently entered an age where we researchers need to both ask for money and ask for help processing our data. But we also, as humans, need something to feel good about and to dream about. And imagining all the amazing things that exist beyond our planet, we need that. In this moment, we need to reach for the stars. If you can give, please join our Patreon at patreon.com/CosmoQuestX, or make a one-time donation by visiting cosmoquest.org/donate. And that's it for now. Good night, everyone. And remember to go out and look up.